Good morning. Myself Prabhar J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is introduction of finite wavelength effect from the unit number 4 in the digital signal processing. Okay, let me discuss. The fundamental operations in the various computational procedure like convolution, spectral estimation, etc. in DSP are multiplication and addition. These operations are performed using the samples of input sequence, impulse response, and the coefficient of the difference equation governing in the system. The informations used for computation are called input data, and the results of the computation are called output data. The input and output data are stored in register in a digital system. The registers are the basic storage device in digital systems. The maximum size of the binary information that can be stored in a register is called register word length. For example, when a register stores an 8-bit data, then its word length is 8-bit. For storing the input data in register, they have to be quantized and coded in binary. The quantization and coding depends on their register word length. Example, when the register word length is 8-bit, we can generate 2 power 8. That means it is which is equal to the 256 binary codes, and so we have 256 quantized levels. The register is used to store the result is 8-bit. Then the result has to be truncated or rounded to accommodate in the register. This makes the system non-linear, leads to limit cycle behavior. The effect of truncation or rounding can be represented in terms of an additive error signal, which is called round of noise. This effect due to finite precision representation of numbers in digital systems are commonly referred to as finite word length effect. The finite word length effect refers to the limitation and inaccuracies that arise when representing and processing numbers in digital system using a limited number of bits. These effects are significant in fields such as DSP and numerical computing, where precise numerical calculation are essential. In digital systems, numerical values are represented using a finite number of bits, which inherently limits the range and precision of these representations. Unlike analog systems that can represent numbers with infinite precision, digital systems must appropriate real world values to fit with the constraints of binary representation. This approximation introduces error commonly known as finite wavelength effect, which can impact the performance and accuracies of digital computations. The following are some of the finite wavelength effect in digital filter. Errors due to quantization of input data by A to D analog to digital converter. Error due to quantization of filter coefficients. Errors due to rounding the product in multiplications. Error due to overflow in additions and limit cycle. Here we have two types of representations, which means numbers representation. First representation is fixed point representation, and second one is floating point representation. In fixed point number representation, numbers are represented within a fixed number of bits for the integer part, and the fixed number of bits in the fractional part. This format is efficient for hardware implementation but can suffer from significant quantization and round off errors. And next type is floating point representation. In this method uses a scientific notation format with a certain number of bits allocated for the significant and exponent. It provides a wider dynamic range and higher precision for a given number of bits, but is more complex to implement. Finite wavelength effects are particularly critical in high precision applications such as scientific computing, telecommunication, audio and video processing, and control systems. Understanding these effects is essential for designing systems that can achieve the desired performance and accuracies. Engineers must balance the trade-offs between precision, computational complexity, and hardware constraint. The finite wavelength effect are a fundamental consideration in the design and implementation of digital systems. By understanding and mitigating the effect, engineers can develop systems that maintain high performance and accuracies despite the limitation imposed by digital representation. Okay, thank you. If you have any doubt, you can ask me through comment. We will meet in next video. Thank you.